Now let's continue with finding domain and range of f and f inverse. So basically the domain of f is actually the inverse of the range of f inverse. So df is equal to range of f inverse, and the range of f is equal to the domain of f inverse. So graph of the f inverse is actually a reflection on axis y equal to x. So now let's look at this example 21. So find the inverse of the following functions and sketch the graph of each functions and its inverse on the same axis. So hence state the domain and range of the inverse function. So we look at the first one. So fx mapping to x cubed minus 1. So we want to find the f inverse of this, and then we sketch the graph of each function and its inverse on the same axis. Okay, now let's do it together. So to find the f inverse, so you use f inverse equal to x. You use these properties. So from there you substitute f inverse into the function f, so which is x cubed minus 1. So you have f inverse of x cubed minus 1 is equal to x. So from here you will get f inverse of x is x plus 1 to the power of 1 over 3. So now we want to sketch the function on the same axis. So this blue color is the f of x. So how to sketch this one? So you see the negative one as the y-intercept, and then when you substitute fx equal to 0, then we'll get x-intercept is equal to 1. So you can sketch this graph. Okay, so this is the f of x. And then next, you want to find the f inverse. So what you do is you just draw a line of y equal to x, and then you just reflect this f function f to f inverse. So how we do this? So you see this is 1 0 1 0, the point. So the inverse should be the other way around, which is 0 1. So you have 1 point here, and then here we have 0 negative 1. So we take the inverse is negative 1 0. So this is the point. So from here we just connect the two and reflect it on the line y equal to x. So from this you can see the domain of f. The domain of f is all the real number from negative infinity to infinity. So the domain of f should be the range of f inverse, which is negative infinity to infinity. So same for range of f. Range of f is also from negative infinity to infinity, and range of f is actually equal to the domain of f inverse. So you'll get this. Now look at for this function gx equal to x plus 1 squared minus 2 for x greater or equal than 0. So why we limit for x only greater than 0? So this is because for quadratic function, so it should be it's not one-to-one function, otherwise we limit the domain. So this is one-to-one function. So if one-to-one function, then we can find the inverse. So we use the properties g of g inverse is equal to x. So from here we just substitute into the gx. So we have g inverse of x plus 1 squared minus 2 is equal to x. From here we'll get g inverse of x is equal to square root of plus 2 square root of x plus 2 minus 1. So where does the negative sign gone? So it's because in the first place because we limit the x is only for greater than 0. So that's why the G inverse is only positive sign. So positive third x plus 2 minus 1. So the domain of f is 0 to infinity. You can see from here. And the range of f inverse should be equal to the domain of f. Okay, so now, so the range of G, so what is the range of G? So this is Gx. Range of G is from -1. So because this is the minimum point for this quadratic function. So we have -1 to infinity. So this range of G is equal to the domain of G inverse. So now we can find, we can sketch the graph. So point 0, -1, here is from 0.4, 0.4. So where to get this one? So you just substitute Gx equal to 0, then you get this. Okay, so because the inverse of G should be the reflex of G at y equal to x. So we can draw this line, and then this 0.40, this point, so we'll inverse as 0, 0.4. Here 0.40. So this point is 0, -1. So when at the inverse side, so it will give you -1, 0. So now you can sketch both graphs on the same axis. Now let's go for the example 22. So find the inverse of Gx equal to 1/1 minus x plus 2. So where x not equal to 1, and state the domain of the inverse function, and sketch Gx and G inverse on the same axis. So we use properties G of G inverse is equal to x to find the inverse of Gx. So substitute into this function. So we have 1/1 minus G inverse of x plus 2 equal to x. So from here we simplify until we get G inverse of x is actually equal to 1 minus 1/x minus 2. So from this, so we know that the domain of G inverse must not have 2. So it means that the domain of G inverse, it should be -infinity to 2 up to 2 to infinity, or you can write as all the real number except 2. So you can write as this as well. So you want to find the domain of the inverse. So this is the domain of the inverse. Now we want to sketch the Gx and G inverse on the same axis. Okay, so now how we do that one? So let's look at Gx. So Gx is green color. So we have this. So Gx, x is not equal to 1. X not equal to 1. So we have this one. So meaning that this is the vertical asymptote. Okay, so next. So if you look at this one, so x cannot be 2. So this is actually 2 is the horizontal asymptote. So this is the graph. Okay, so you can substitute any value to get the graph. And then the G inverse should be the other way around. So it should be the reflex at y equal to x. So from this point 3, 2, so it should be 3, 2 over here. And then so for this line, x equal to 1, you should have y equal to 1. X equal to 2, you should have y is equal to 2. So all is in inverse. So from there you just plot in. So here you have 3, 0. So you must have this point as well. So 0, 3. So you can continue drawing. Okay, until you get as this. For n inverse functions, so f inverse and then inverse, you will get F. F composite G inverse is actually G inverse composite F inverse. For example, you are given two functions. So ux is equal to 3x squared minus 4. This is for x greater or equal than 0. So and ubx is equal to 1 over 2x minus 3. So where x is not equal to 3 over 2. So you want to find the u inverse and v inverse. So for u inverse, so you just substitute in. So u inverse is equal to x. So you have 3 u inverse to the power of 2 minus 4 is equal to x. Then finally, you'll get u inverse is equal to plus minus square root of x plus 4 over 3. But then because of the domain for x is greater than 0, so you just take the positive value of u inverse. So you get u inverse of x is equal to square root of x plus 4 over 3. So now to find the v inverse. So 1 over 2x minus 3, x is not equal to 3 over 2. So same as u, so v inverse is equal to x. So substitute into v, then you get 1 over 2 v inverse minus 3 is equal to x. So you simplify this by cross multiply, then you get v inverse is equal to 1 over 2x plus 3 over 2, or you can simplify as this. Okay, now how to find u inverse? So v u inverse is actually u inverse v inverse. So you have find your v inverse. So you substitute your v inverse in u inverse, then you'll get this one, and finally you'll get this one. So because u inverse is square root of x plus 4 over 3, so your v inverse is 1 over 2x plus 3 over 2. Substitute this one into this one. So finally you'll get this. I think that's all for today's lecture. So we'll continue more in lecture 4. Thank you. So now please answer this question and send the solution as a proof of your attendance. The question is, find the inverse of f mapping x to the power of 3 minus 8.